Hello and welcome back to our video tutorial series on how to use GreenScenario. In this episode, I'm going to show you how to utilize some of Grasshopper's built-in components to create more variety in our drawings and then speed up some of the workflows. One of the examples would be currently in the drawing over here, we have only one scenario, and it's a very basic one. We have a landscape material defined as asphalt, and we have an extensive arc projected on this curve. But the thing is that we don't really have any design yet to this curve, and we would like to keep it as flexible as possible, but we would like to populate the model with some trees. So what you could do is obviously position some points manually over here, and then grab a tree component, connect it to a point input, select multiple points from the drawing, connect these, and then generate it this way. But then what if, for example, this curve needs to move or its shape or size changes, then these trees would also have to be moved manually. So, and also if we don't particularly care about the layout of the trees just yet, we just want to understand what is their effect on different KPIs, and how would different quantities of trees, the different amounts of trees, what kind of effect would they have. So what we could do instead is we could generate a slightly different, or adopt a slightly different approach to generating these trees. And so let's do it just now. Let's say that we would like to use a populate 2D component, which is residing under vector and grid, populate 2D. And what it essentially does is it takes a region and populates it with randomly distributed points. And so we could try and say, let's take this curve over here, but then what it does, it's kind of like trying to approximate the shape of the curve and then see whether the tree falls within it, and then just populate it there. So what we could do is we could say, okay, this is our curve, and generate whatever the number of trees here is. So let's just say, let's say 150 trees, for example, or 150 points. And some of these points, as you see, we can have more or less. Some of these points would fall within the shape, and some would be without. And depending on the shape of the curve, it might result in more or less points. For example, over here, like this region will be completely neglected. So what I like to do is I would like to take actually the outside curve and bring this as input and populate the entire project area with these points. And then what I would do is I would just make a check whether a point is in curve, point in curve. And the component over here is located under curve, and then there is this analysis and point and curve component. And then we can say whether the generated points, are they enclosed in the curve that we're actually interested in, so in this one. And right now we have a list of relationships, and you can see it has gone through 550 different points, and it's telling us either it's outside of it, within the curve, or on the curve. And now we just need to sort through our list. So it's under sets, sequences, and cull pattern. So we're just culling the list of our points that we're interested in. So these are these ones, and then the relationship is going to cull it. So right now I can highlight it and see these are only the points that I'm actually interested in. So I can select these two and then just turn off their preview so that they don't get in the way. Now you can see that we have a very flexible setup that allows us to change the density of the trees in the drawing, and then you'll see that it is going to always adapt, no matter how big the curve is or no matter its location, it's always going to follow. So now that we have all this prepared, let's just move or connect all the dots together. And let's see what's happening. Okay. So one of the reasons why it broke right now is I can see that it's generating a tree of data over here. So we just need to flatten this component, the output from this component, to make sure that a list of components is being fed into our scenarios. So again, right click, flatten the output, and we can see that it's way too many trees, that density is way too high. We can play with that, and then very easily we have generated the inputs. Please bear in mind that in this approach, the number 57 is not the final amount of trees. It's 57 points are going to be populated across the entire drawing, and only the ones falling within the bounds of this curve are going to actually commit to populating this with trees. And then another step that we could take is if, for example, we were to say that this is a three-dimensional drawing, so we wanted to raise this green area element above the surrounding terrain. We could also, then we would see, yeah, but our points, they fall within the boundary, but they still remain at 0. So again, we could use Grasshopper's tools, and there is a project to plane, project plane, project, to find it, no, sorry, it's move to plane, not project to plane. So move to plane is a component that's also built into Grasshopper, and it's under transform. We can see it here, move to plane. And what do we want to move? We want to move the points that have that we have called before. And then what is the plane? The plane is actually the it's defined by the curve that delineates our green area. So this is this plane. And then now if we reconnect them, you'll see that it automatically will also follow any terrain changes that we'll do. So right now we have a very parametric setup of our drawing where we don't really need to think about the distribution of our trees over here. We can just draw the curve or control it with our green area curve, and also control the density with the amount of trees that we're populating over here. And we still have individual control over their size, whether they are preserved or planted, or what type do they represent. If we wanted to have more control over this, because right now it's one component that all trees are being defined by, we would have to use the developer mode and use our automation parameters, and then input multiple values per the amount of trees that are being fed into this component over here.